Hello, everyone. Welcome to another episode of Scaling with Demi. I got a message, a WhatsApp message from a friend, Daniel. He was telling me about an article that Program wrote in 2009 about what made Twitter special as of 2009. I don't know if it's special, if it's still special now. But then he also sent another message that talked about Twitter becoming a protocol from just a regular social platform. And this got me thinking about protocols deeper. The email protocol has really stood the test of time. It has stood the test of the mobile revolution, the desktop evolution. I don't know if we'll still be sending emails in AR and VR, maybe, or in the metaverse, or I don't know, blockchain emails. I don't know. But then it got me thinking about email protocols generally. How do they work? I mean, I've kind of configured some email servers in the past, done something, but what are the systems that really go behind it? What are the different kind of protocols they implement and how do they work? And in this video, I'm going to be talking about email protocols. Maybe later I'll talk about Twitter protocols or what it could have been when it became a protocol. But for this one, I'm going to be exploring emails. What really goes on behind the scene when you send an email or when you receive an email. Let's go. So, what is a protocol? A protocol is just a standard, a convention, set of agreed, standardized system between a receiver or a recipient in this case, or a sender, who is the person like the system or the client sending the message, right? So it's like, think of it like a language, like English language, right? When I say go, you have to understand what go means for you to be able to go, right? So there has to be a clear set of principles that guide our communication. If I say something like, go there, buy, eat food, rice tomorrow, that does not make any sense. Even though I literally said words that are valid, I did not follow the standard English, I don't know, those boring stuff that they used to teach in secondary school. Concord, single pronoun, single first person principle. The way languages, English, French, Yoruba, Igbo, have um, clearly defined systems, standards that you have to follow is the same way you design a communication protocol. Except that this communication protocol is used between two different systems, two different computer system or technical system, right? So you need to define what the client will be sending. In this case, what kind of data will the client be sending? Is it a string, a number, a JSON, a buffer? And what kind of data the receiver will be receiving? And even within the type of data the client and the receiver are both sending and receiving, you have to specify, you have like an header, for example, where is it coming from, who is it sending, where is sending it to, how do you describe the packet you are sending. You can design your own protocol. I think I talked about that in the video that you'll be seeing in the future. So just subscribe, like, so that you receive notification when I drop that video. So the communication protocols are just pretty simple like that, right? When you think of most web protocols, right, most of them depend on DNS. It's important to understand how DNS works, right? To really understand the how we make protocol work. Like that's a major critical step in how your email will get processed. How almost everything on the internet gets actually processed, right? So the DNS is just a database, right? It's just like a bucket, key value pairs that takes a domain name. A domain name could be demi.ng, youtube.com, tiktok.com, facebook.com, and maps it to an IP address. So every system on the network has an IP address attached to it. Your local is going to be 127.0.0.1. Google has its own IP address. You can Google it. Facebook has its own IP address, or set of IP addresses, because you can have multiple IP addresses attached to a particular system. So every system has its own IP address attached. But because humans, we like to keep things simple. We don't like complex numbers, a lot of numbers. We like names. We now built a form of database, right? Let me just quickly do a quick sketch here. So you have a form of database that says, I have an IP address here, and I have the domain name. So we're just going to take an IP address, call it, this is not an actual, it's probably an actual IP address, I don't know, I'm just coming up with it off the top of my head. So let's just say 196.7.2.1. And imagine I want to go to a website and I'm going to 196.7.2, but I'm definitely not going to remember this. That's because I want to order food and I have to go to this website. So we say, okay, let's map it to something like demi.ng. This is not the actual IP address mapping, just random. So let's map something like demi.ng. So what happens is when you go to demi.ng, your browser now goes to check that DNS, this DNS table here, to say, oh, what's the IP address attached? Because the real browser actually has to go to the IP address, not to the domain name. And there's something called a port. So in a system, almost any system, there are ports in which processes run on. You can have a port 80, port 443, port 272, a port can be any number really. So when I go to an IP address, and I specify the port. So maybe 172.3.4.5, port 50. I'm saying this is the system here, and this is the port I want you to go. This is the process I'm referring to on that system. So I've mentioned the IP address, I've mentioned the port system and the standard ports that this works on. So let's go back to email and you see why this is relevant. So how does an email even work? Like I sent an email to my boss that, so I'm done with this work. I cannot take it anymore. I'm tired. You're stressing me. The toxic workplace. How does it work behind the hood, right? So I've outlined the step of the flow that really happens here, right? And the first thing is like the sender, which is me in this case, because I'm the one sending the email. I'm the provoked person, provoked individual here. Sender opens his email client. Then the email client or the web-based email service uses the SMTP protocol. Remember I mentioned protocol before. There is HTTP, there is HTTPS, there is SSH, there is TCP, there is RDP for remote desktop protocol for accessing someone's laptop using GUI. There are so many protocols out there, right? So there's the SMTP protocol, which is what email uses to send, most email clients use to send an email to a receiver. So it's called the Simple Mail Transfer Protocol. So the client uses the SMTP to send it to my email server, and the receiver uses either of these two, the POP or the IMAP. If you've ever configured your own email client, you would have seen an option to use IMAP or SMTP, IMAP or POP. I'll tell you the difference between these two, if I remember. Then the recipient client receives the email and displays on the recipient browser. So all this drama goes on just because I want to send I don't want to work here again anymore, boss, to my boss. All this now happens. So let's just divert a little bit. I like diverting, I know, and talk about the MX record in this case, right? There are different types of record that are stored in the DNS. I just did a simple, for a DNS system I did initially, I did a simple domain name and IP address. But I lied. I'm sorry, I lied. It's a little bit more complex than that. You have different types of record in a DNS system. You have the A record. I don't know why they call it the A record. Maybe it's like an OG kind of record, the immediate record, the first record. But an A record maps a domain name to an IP address, like we discussed earlier, right? So you have a domain name, demi.ng, you get an IP address that you map it to, or a domain name pleather.com, and you have an IP address that you map it to one-to-one mapping. Chicken out, simple. And domain name, IP address, one-to-one mapping. That's simple. That seems like the base of every system, right? Base of the internet. Then you have a CNAME record. I like writing. So the CNAME record maps one domain name to another domain name. You have a lot of other records. You have the TXT record. It's just for putting a lot of jargons on the web to verify that you're doing it on the server, for a lot of other things. Not jargons, but just to, you want, for different purposes, right, actually. You want to just store something against a particular domain name. You want to identify a particular key that you're doing of the domain, whatever. But you have an MX record, which is what we're talking about. And these are some weird syntax attached to it, which I won't go into. But this one is simply just for saying that, oh, this is the mail exchange value. It helps you identify the server that this mail exchange is resolving to, right? Simple. So that's just for the mail records. So in the flow we talked about earlier, the sender identifies the mail record, the MX record, to get the MX record from the DNS to identify the receiver of this email. And then after getting the IP address through multiple resolutions, it then sends the email to that server. Right? It's quite simple. I also said I'll talk about POP and IMAP, the two different protocols the receiver uses to actually fetch data. Right? So when someone sends an email to me, maybe my boss is like, oh no, you are definitely not going anywhere. You're such an awesome engineer. I really love you. You're not going anywhere. I'm going to double your salary or quadruple your salary. And I'm like, yeah. So how does my system actually receive that email? Don't forget, we use SMTP to send it. For receiving, we use POP or IMAP. POP is a little bit old, post office protocol. I think that's what they call it. So it's kind of, the way it works in the post office. You send someone to deliver my letter, I receive the letter. Yeah, so you don't go. I can't call the mailman again to give me my letter again because I received it. So when you log into a client that uses a POP, or you configure your own email client to use POP, you can actually configure it in your Gmail. Just check it out. You can configure it in your Gmail. So when you configure your email client to use POP, what happens is, once it fetches it it downloads the record from the server and deletes it. So you just download it to your client, which means if you log into another client on your phone, maybe you download it on your laptop, you view the email on your laptop, when you go to your phone to open your email, you will not see that email there. which is not something we like in 2022 because of we like to keep all our records, and I like to have 5 million emails that are unread. I don't like it, but I really have no choice. A lot of unread messages, and even the ones I read, they're just there. I don't delete it. So we like to keep things in 2022, except snaps. People don't like to keep snaps, but generally we like to keep things. But the IMAP is a much more modern protocol, and what that does is it actually does not delete it from the server. Right? You just fetch the record, and you can keep fetching it from multiple devices. It just changes the status to read. So whatever the implementation the client is, changes the record to read. But if I open my phone, I can still see another IMAP. I can still see an email that I've read on my laptop. So basically, the POP deletes it from the server. The IMAP does not delete from the server. SMTP is for sending, POP and IMAP for receiving. POP deletes from the server after reading it. SMTP does not delete from the server. So if you are going to be doing something illegal, which I absolutely advise against, use POP. Actually, you're not in control of whatever your client is really, because you are the one that is sending it, except you are receiving. It doesn't matter. So yeah, that's that. Another thing I want to just really touch on before I round this up is the different fields. So you know this BCC, CC2? It is your email provider that actually decides to honor those contracts. So in reality, when an email is sent, the headers contains the to, the from, the reply to, the BCC emails, the CC emails, and all these things. But you can actually design an email client that will just even show the emails that are on BCC. So usually it's just the client, the email provider that says, oh, because of this is standard, I'm just going to not show BCC. So as a receiver, you don't see, oh, this email have been BCC too. But if I want to design an email client, maybe I'll just decide to just screw people over and just show the BCC. So you're copying my boss to tell him that I did not do my work, Abby. Very good. I know who is snitching on me. I know who you're copying, who you're blind copying. But usually, clients are much more graceful than I am, and they will design their email clients, like maybe Google, Thunderbird, there are a lot of email clients out there, in a way that they honor the contract. So when a sender sends a BCC, even though they have access to the BCC on the front end, they just decide not to show the receiver the BCC. Right? So that's just one thing to note. It's BCC ID is actually not embedded inside the SMTP or the POP or IMAP protocol itself. It's just a front-end dramatic something. Okay, so that's gonna be it. I think this was short. I don't know how many minutes I spent. A little bit shorter than others. I hope you learned one or two things. If there is something you want me to talk about, just let me know in the chat. Send me a tweet on my Twitter. Yeah. I'm not an expert in any of these things, disclaimer. I'm just trying to have fun, learn new things. So don't forget to like and subscribe so that you get notified on my next interesting or non-interesting video. Thank you. Cheers.